A software development methodology divides the software development in various distinct phases, and each phase focuses to achieve one main goal each. This is software development life cycle. There are various SDLC models, and the oldest form is waterfall model, which is the topic of this lecture. Next, the waterfall model illustrates one of the earliest embedded development process, which is in a linear sequential flow in embedded development product life cycle. This means that any phases in the development process begins only if the previous phase is completed and the flow is unidirectional, hence the phases do not overlap. The outcome of one phase acts as the input for the next phase sequentially. It establishes analysis and design with highly structured development phases. It implements extensive review system to ensure the process flow is going in the right direction. The features of linear model is that the bugs in the current design are not corrected immediately and development proceeds with the current design. The fixing of bugs is done in support and deployment phase. Waterfall model is a sequential model that divides software development into predefined phases. This is a linear sequential flow in which progress is seen as flowing steadily downwards through the phase of software implementation. This downward flowing concept of this SDLC is what gives it the name of waterfall model. Every phase will need to be completed before we go on to the next phase. That is, every phase need reviewed and completed. Only then we can proceed to next phase. Each phase is designed for performing specific activity during the SDLC phase. It was introduced by Winston Royce in 1970, but the term waterfall introduced in 1976 by Bell and Thayer. Next, the following illustration is a representation of the different phases of waterfall model. They are requirement analysis, which comprises of need, conceptualization, analysis. Next is system design, implementation, testing, deployment, maintenance and upgrades, retirement. Requirement analysis. During this phase, all the possible requirements of the system to be developed are captured and documented in a requirement specification document. The documents are reviewed and signed off, after which the project moves into system design. The requirement specification from the first phase are studied in this phase and the system design is prepared. This system design helps in specifying hardware and system requirements and helps in defining the overall system architecture. Once the design phase is over, the project will move to implementation phase, where the developers converts the design into code. Developer will code modules which are then integrated into a complete software. The implementation phase will generate the developed software as a working application according to user requirements. Next phase is testing. All the units developed in the implementation phase are integrated into a system after testing of each unit. Post integration, the entire system is tested for any faults and failures. And deployment of system. Once the functional and non-functional testing is done, the product is deployed in customer environment or released into the market. Next is maintenance. There are some issues which come up in the client environment. To fix those issues, patches are released. Also, to enhance the product, some better versions are released. Maintenance is done to deliver these changes into customer environment. And next is retirement or product disposal. And next is the advantages of waterfall model. This is simple and easy to understand and use. Easy to manage due to the rigidity of the model. Each phase has specific deliverables and review process, and good control over cost and schedule. And is documentation is easy. Phases are processed and completed one at a time. Works well for small projects where requirements are very well understood and clearly defined stages. Next, these are some drawbacks of the waterfall models. It assumes all the analysis can be done without doing any design or implementation. The risk analysis is performed only once. The working product is available only at the end of the development phase. Bug fixes and correction are performed only at the maintenance or support phases of the lifecycle. And it is difficult to measure progress within the stage and cannot accommodate changing requirements. Not suitable for the project where the requirements are at a moderate to high risk of changing, and this is not a good model for complex projects. And next is where to use the SDLC waterfall model. Waterfall model can be used when the requirements are not changing frequently, application is not complicated and big, when the project is short, requirement is clear. Technology and tools used are not dynamic and stable.
Okay. Now, as from the introduction, we have seen there are two types of models, which would be the waterfall model and the tool chain model. Here, I'm going to explain about the tool chain model. Okay, these are embedded software development, which requires a even wider range of tools like editors, compilers, debuggers, profilers, etc., which would help to give a greater productivity. The generic tool chain for development of embedded applications, which involves the integration of many tools like editor, preprocessor, cross-assembler, cross-compiler, linker, locator, debuggers, and loader or target programmers. Next slide. Okay, here we're going to describe about each part of the toolchain system. Here, first is the editor. Editors are basic things, basic programs which come along with the operating system, in which we could do some basic editing like text editings, etc., and from high level to high level editings like program editing or source code editing. Next comes the preprocessor. The preprocessor directives are the lines included in the code of programs but are not included inside the program. They are just the program statements, which are the directives for the preprocessor. They are mainly used to ease the program. For example, when we use the print statement or the input output statement, etc., they would simplify these preprocessor directives would simplify it. Next comes the assembler as well as the compiler. Here we have three kind of languages, which would be machine language, assembly language, as well as high level language. Then in assembly language, to convert the assembly language into machine language, an assembler is used. The assembly language would be mainly consisting of mnemonics, so assembler is used. Next comes the compiler, the high level language which is easily understandable to human, is being compiled or is being executed with the help of compiler to machine language. Next slide, please. Okay, then the linker comes. Okay, the program which is being executed with the help of compiler as well as the assembler is being compiled or is being combined into a single executable program with the help of linker. Next comes the locator. It does the linking and loading of the object programs. Next, the debugger. If when after compiling and the linking process, if any error or any correction is need to be done, it is identified with the help of debugger. Next comes the loader or target programmer. A loader is an operating system utility that copies programs from a storage device to main memory, where they can be executed and also replace virtual addresses with physical address. Next slide, please. Next, as a summary of what we said about the toolchain system, here is a flowchart which would easily describe about it. First comes the developer. The developer has an idea of a code and he would implement it by writing the code or the program with the help of an editor. Then when he writes the program in the editor, it would become a source program. Then it would pass to the preprocessor. As we said, we have two types of language for humans, which would be assembly language as well as high level language. This preprocessor would identify which language it would execute, and then it would give it to either compiler or to the assembler. Then it goes to the object program and then to the link locator, and then the program is executed, and from there before executing it is passed on to the debugger so to check any errors, etc. Then it goes to the target programmers and then to the target system. Thank you.